Hello students, good afternoon. You are welcome in the lecture number 9 of MHTCET of a chapter of chemical thermodynamics. In this lecture, we are supposed to focus on these 3 points, that is enthalpy of phase transition, then thermochemistry and then thermochemical equations. Now let us see these points one by one. First one, enthalpy of phase transition. What is meant by phase transition? We know there are 3 phases: solid, liquid and gas. Whenever solid is converted to liquid, the process is known as fusion. Solid, whenever converted to liquid, it is nothing but the fusion. This process is known as fusion of solid. Other way, whenever liquid is converted to solid, it is known as solidification. This process is nothing but the solidification. Further, whenever liquid is heated, converted to gas, this process is known as vaporization. It is the vaporization or evaporation. And gas, whenever converted to liquid, this is known as condensation. This process is condensation. And one more is there, whenever solid is directly converted to gas without passing through the liquid state, it is known as sublimation. Or whenever gas on cooling directly converted to solid without undergoing the liquid state, it is also known as sublimation. So these are the phase transitions. One phase of a substance is converted to another phase, and at that time either heat is released or heat is absorbed. Change in heat take place, that is known as enthalpy of phase transition. Phase is changing, transition of the phase take place, and the enthalpy change observed over there is therefore known as enthalpy of phase transition. Now very simple, since we know all these processes and their names, enthalpy of phase transition is very simple to explain over here. Whenever solid is converted to liquid, the process is known as fusion. It means that whenever 1 mole of solid, how many moles? 1 mole of solid is converted to liquid at a given constant temperature and pressure. The change in enthalpy is known as enthalpy of fusion. Enthalpy of fusion is the enthalpy change whenever 1 mole of solid is converted to liquid at constant temperature and pressure. Very simple. Liquid is converted to solid, it is known as solidification, and enthalpy change is enthalpy of solidification. That enthalpy of solidification is defined as enthalpy change whenever 1 mole of liquid is converted to solid at constant temperature and pressure. Fusion and solidification are opposite processes of each other. Now liquid whenever converted to gas, it is known as vaporization or evaporation. And enthalpy of vaporization is the enthalpy change whenever 1 mole of liquid is converted to gas at constant temperature and pressure. Opposite of this vaporization is condensation. So enthalpy of condensation is the enthalpy change whenever 1 mole of gas is converted to liquid at constant temperature and pressure. Very simple. Whenever solid is converted to gas or gas is converted to solid without passing through the liquid phase, it is known as sublimation. So enthalpy of sublimation is defined as enthalpy change whenever 1 mole of solid is converted to gas at constant temperature and pressure without passing through liquid phase, or enthalpy change whenever 1 mole of gas is converted to solid without passing through the liquid phase is also known as enthalpy of sublimation. So these are the phase transitions. Transition of phase take place, and the change in enthalpy is therefore known as enthalpy of phase transition. Ice, whenever heated, converted to liquid water, that is enthalpy of fusion. Liquid water, whenever heated, converted to gaseous water, water vapors, that is known as enthalpy of vaporization. And the summation of enthalpy of fusion and enthalpy of vaporization, that summation is known as enthalpy of sublimation. Because over here there is solid converted to liquid, here liquid converted to gas. If these two phases are added, if these two steps 1 and 2, if these two steps are added, what happen? Liquid get cancelled and we will get solid directly converted to gas. We will get this equation. Therefore, the summation of enthalpy of fusion and enthalpy of vaporization is also known as enthalpy of sublimation, because by adding the enthalpy of fusion and enthalpy of vaporization, we will get the equation of enthalpy of sublimation. Further, enthalpy of atomization is there. Enthalpy of atomization means atoms are formed from the molecule. Molecule undergo breaking, Cl, this is a molecule. The bond between the atoms will be broken, forming Cl plus Cl. Two atoms are separated from the molecule. It is known as enthalpy of atomization. So what is the definition? Like this, enthalpy of atomization is the enthalpy change whenever 1 mole of molecule is converted to atoms. And this enthalpy of atomization is endothermic. Always take place with absorption of heat, absorption of energy. Enthalpy of ionization. Enthalpy of ionization. For example, sodium converted to Na plus 1 electron. Electron is lost and neutral atom is converted to ion. The enthalpy change is known as enthalpy of ionization. So enthalpy of ionization is the enthalpy change whenever all atoms in 1 mole atom are converted to ion at constant temperature and pressure. Particular values are there. Here it is 242, here it is 494 joule, like that. Then enthalpy of solution is important. How the solution is prepared? Solute is added to the solvent. Solute, whenever added to the solvent, it forms a homogeneous mixture known as solution. Solute is dissolved in the solvent known as solution. Solute is the component taken in less proportion. Solvent is a component taken in more proportion. And solute and solvent homogeneous mixture gives the solution. For example, suppose this is the solute NaCl. Whenever it is added to water, first of all what happen? NaCl will undergo breaking, forming Na plus and Cl minus ions. This breaking is known as crystal lattice enthalpy. The breaking of NaCl take place to form Na plus and Cl minus ions. The energy change is known as crystal lattice enthalpy. And we know always breaking of bond is endothermic. Breaking of bond absorb energy. Therefore, crystal lattice enthalpy is always positive value. It has always a positive magnitude. Why positive magnitude? Because there is a breaking of bond take place between the atoms forming ions. That is known as crystal lattice enthalpy, and it is always having a positive magnitude. Whenever this is to be added to the water, now each Na plus ion is covered from all sides by water. This is known as a solvation process. It is the hydration process. Similarly, each Cl minus ion is covered from all sides by water. That is known as solvation. Since water is used, solvation is also known as hydration. This process is solvation, and because water is used, it is also known as hydration. This is positive change, energy is absorbed, breaking of bond. Here is the formation of bond. Formation of bond take place. Since breaking of bond is endothermic, formation of bond is exothermic. So enthalpy of hydration is negative. It has a negative magnitude. And suppose, for example, for NaCl, crystal lattice enthalpy is plus 790 kilojoule per mole. Here enthalpy of hydration is minus 786 kilojoule per mole. If we do the summation, whenever NaCl is added to water, there is plus 4 kilojoule change take place. Change in enthalpy is plus 4 kilojoule. Means the preparation of NaCl solution in water is endothermic. That is endothermic, take place with absorption of energy. So the summation of crystal lattice enthalpy and enthalpy of hydration is known as enthalpy of solution. Enthalpy of solution is the enthalpy change whenever 1 mole of solute is added to particular quantity of a solvent to form a solution of known concentration is known as enthalpy of solution. So that is there about the enthalpies of phase transition. Now let us see what is meant by thermochemistry. Thermochemistry is a branch of chemistry which deals with study of heat changes accompanying the chemical reaction. Whenever the chemical reaction takes place, either heat is lost or heat is absorbed. Accordingly, there are two types of reactions. They are known as endothermic and exothermic reactions, and they are studied with the help of branch of chemistry known as thermochemistry. Let us see over here. Suppose we have the general reaction A plus B giving C plus D. If these two reactants are having the energy 100 kilojoule, C plus D, these are the products having energy 110 kilojoule. So what happens? Reactants has less energy and they are converted to product, where products are having a greater energy. So how it take place? 100 and this is 110, means reactant have absorbed heat. How much? Plus 10 kilojoule they have absorbed. Absorption of energy take place. This type of reaction is known as endothermic chemical reaction. This is the endothermic chemical reaction. The reaction which is taking place with absorption of heat is known as endothermic chemical reaction. For this reaction, this is H1 initial state value, this is H2 final state value. Delta H is nothing but H2 minus H1, so it is always positive. 110 minus 100, always delta H is positive for endothermic chemical reaction. And we know energy and stability are inversely proportional to each other. Energy and reactivity are directly proportional to each other. Energy and stability are inversely proportional to each other. Energy of product is more, they are less stable. Energy of reactant is less, they are more stable. So in the endothermic reaction, reactants are more stable than the product, because delta H is always positive, and these are the reactions taking place with absorption of heat. See the other type of reaction. Let the one more reaction, A plus B giving C plus B. Here reactants are having energy 100 kilojoule, but products will have energy 90 kilojoule. 90. So where 10 goes, where 10 kilojoule energy goes, that is lost. Whenever reactants are converted to product with evolution of heat, loss of heat, those reactions are known as exothermic chemical reactions, for which this is H1, this is H2. What is the value of delta H now? Is it positive or is it negative? This is negative, because H2 minus H1, 90 minus 100, it is negative. And products are having less energy as compared with reactant. Therefore, in exothermic reaction, products are more stable than the reactants. Products are more stable than the reactants. That is only there about thermochemistry. And we can calculate the enthalpy change by this equation. Enthalpy of product minus enthalpy of reactant, or the summation of enthalpy of product minus summation of enthalpy of reactant is known as enthalpy of the reaction, that is studied in the thermochemistry. So thermochemistry is a branch of chemistry which deals with study of heat changes accompanying the chemical reaction. Accordingly, two type of chemical reactions are studied with the help of thermochemistry. They are endothermic and exothermic chemical reactions. Now see thermochemical equations. What is meant by thermochemical equation? Suppose this is the reaction, carbon plus oxygen giving CO2. This is a balanced reaction. But can we come to know whether the forward reaction is exothermic or endothermic? No, not known. Whether this reaction is taking place with absorption of heat or evolution of heat, we don't know over here from this reaction. But if I write delta H will equal to minus 393 kilojoule. Now you can tell me what is the nature of forward reaction. Is it endothermic or exothermic? Exothermic, because minus sign. Do you know the states of reactant and product here? No, we don't know. But if I write CsO2G, CO2G, now you can tell me easily the states. Carbon is present in solid state, oxygen in gaseous state, CO2 obtained in the gaseous state. So this type of equation, balanced chemical reaction in which number of moles of reactant and product are balanced, in which states of reactant and states of product are mentioned, in which the enthalpy change is mentioned, specified. That type of reaction, that type of equation is known as a thermochemical equation. So thermochemical equation is nothing but the balanced chemical equation in which number of moles of reactant and product are balanced, in which states of reactant and product are properly mentioned, in which the enthalpy of reaction with a proper sign is mentioned, specified, is known as thermochemical equation. We have seen the rules in detail in our regular class lecture to convert simple chemical equation to the thermochemical equation. There we have seen S is used for solid state reactant product, G is used for gaseous state reactant and product, L or AQ is used for liquid state, aqueous state reactant or product. Negative sign indicates the reaction is exothermic. Backward reaction will be endothermic. The whole thermochemical equation can be written in opposite manner just by changing the sign of delta H. That is about the thermochemical equation. Now let us see some multiple choice questions based on these 3 points of enthalpy of phase transition, thermochemistry and thermochemical equations. We are using the target book, and from that book we are taking the questions. Now see, classical thinking questions, basic questions, classical thinking questions based on enthalpy of physical changes. First is question number 38. There is a question number 38. The enthalpy change for the reaction H2O solid to H2O liquid is called enthalpy of. They have given H2O solid converted to H2O liquid. Enthalpy of phase transition, solid to liquid. What is the name of process? Fusion. And what is the enthalpy change of that process? Enthalpy of fusion. Very simple. That is enthalpy of fusion. They have given question number 38. The enthalpy change for that reaction H2O solid to liquid is called enthalpy of option A vaporization, B fusion, C combustion and D transition. So second option B is correct. It is the enthalpy of fusion. Solid converted to liquid is known as enthalpy of fusion. Liquid to solid, enthalpy of solidification. Then liquid to gas, enthalpy of vaporization. Gas to liquid, enthalpy of condensation. Solid to gas, that is enthalpy of sublimation. Here is the solid to liquid, so that is known as enthalpy of fusion. So second option B is correct. Next question, question number 39. Enthalpy change of reaction does not depend upon. Enthalpy is a state function. We have studied it. Enthalpy is a state function, and state function is a physical quantity of which change in magnitude depends on magnitude in initial state and magnitude in the final state. but not depending on the path, not depending on path used during that conversion from initial state to final state. So let us see 4 options. Enthalpy change of reaction does not depend upon option A, condition of reaction. It depends on condition of reaction. Second, initial and final concentration. It depends initial and final concentration. Physical state of reactant and product, that also depend. Only last option, number of steps in the reaction. Enthalpy change is not depending on the number of steps, because we have seen solid is converted to liquid, and liquid whenever converted to gas. See this one, solid to liquid. Whenever liquid is converted to gas, if we add together, solid is converted to gas, because liquid cancel. If here it is X, this is Y, solid to gas is nothing but X plus Y. So is that enthalpy change depending on the steps? No, it is always constant, independent of steps. One law is there. That law also we have to study, maybe in the next lecture. That is known as Hess law of constant heat summation. So here option D is correct. Now see question number 41, not 40, question number 41. It is thermochemistry is concerned with study of. I have told you it is thermochemistry. Thermochemistry is a branch of chemistry which deals with study of heat changes accompanying the chemical reaction. Heat changes accompanying the chemical reaction is known as thermochemistry. Here the question is, thermochemistry is concerned with the study of option A, change in temperature, B, change in heat energy, change in volume, change in internal energy. So what is studied here? Change in enthalpy means change in heat energy. So option number, I think this is the second option. Option B is correct, because thermochemistry is a branch of chemistry which deals with study of heat changes accompanying the chemical reaction. So second option, change in heat energy, is correct. Next, 42. The heat of reaction does not depend upon. 42. The heat of reaction does not depend upon. Which factor? It is not depending on path or steps. Just now we have studied. Steps not depending, or path not depending. Option A, temperature of reaction, it depends. B, physical state of reactant and product, state of system is important. Whether reaction is carried out at constant pressure and constant volume, that also makes the matter on heat of reaction. Last option, the method by which final products are obtained from reactant. Method means path. Method is nothing but the path used for conversion of reactant to the product. Therefore, last option is correct over here. Option D. Last option is correct. The heat of reaction does not depend upon the method by which final products are obtained from the reactants. Next, question number 43. The heat of chemical reaction is given by the following expression. 43. Heat of reaction is given by which of the following equation? How we have calculated heat of reaction? Delta H is equal to H2 minus H1, or that is summation of enthalpy of product minus summation of enthalpy of the reactant. So let us see 4 options. Here they have given option C. This is the third option they have given. The heat of chemical reaction is delta H is equal to summation of enthalpy of product minus enthalpy of reactant, that is final state minus initial state. So for question number 43, option C is correct. Now question number 34. A chemical reaction in which heat is absorbed from surrounding with increase in enthalpy is called. Question on thermochemistry. The reaction which is taking place with increase in enthalpy. Reactants are converted to product and enthalpy increases. Reactants converted to product and enthalpy increases. Just now we have seen this equation. A plus B converted to C plus D. They are having 100. They are having 110 increases. So which is this type of reaction? Exothermic or endothermic? Endothermic reaction. This reaction which is taking place with increase in enthalpy is known as endothermic reaction. So here option A is correct. Now see question number 45. Study the following two reactions. Here they have given two reactions. First is CH4 plus 2O2 giving CO2 plus 2H2O. Very simple question. We have to identify the nature of reactions. For first reaction, they have given delta H negative minus 890.4 kilojoule, and for the second reaction, they have given delta H positive, and we have to identify the nature. We know if delta H is negative, what is the nature of this reaction? Endothermic or exothermic? Exothermic. For second reaction, delta H is positive. What is the nature of this reaction? Endothermic or exothermic? Endothermic. So which option is correct? That option is correct, in which first equation is written as exothermic and second is given as endothermic. So let us see four options. First is both reactions are exothermic, wrong. Second, both are endothermic, wrong. Third, reaction 1 endothermic and 2 exothermic they are telling, so that is also wrong. And last, reaction 1 is exothermic and 2 is endothermic, that is correct. So option D is correct. Now question number 46. See question number 46. Evaporation of water is, evaporation of water, is it exothermic change or endothermic change? Whenever liquid is heated, it is converted to gas. Means water is necessary to be heated to convert to the vapors, and that is known as evaporation. So evaporation of water take place by absorption of heat. Therefore evaporation of water is endothermic change. They are given four options. Option A endothermic, B exothermic, C a process where no heat change occurs, D a process accompanied by chemical reaction. There is no chemical reaction, just phase transition take place. Phase transition. Liquid phase is converted to gaseous phase. Phase transition take place, and that is endothermic change taking place with absorption of energy. So for 46, option A is correct. Now 47. An exothermic reaction is one in which the reacting substances, see, which is having greater energy in exothermic. That is what we have to identify. Whenever exothermic reaction takes place, suppose A plus B converted to C plus D, they are having energy 100. C plus D, is it greater than 100 or less than 100 in exothermic change? Exothermic change. So product has less energy or more energy than the reactants they are having less energy 90 because certain energy is lost. Therefore, energy of product is less than energy of the reactant. Now let us see the options. Option A have more energy than product, that is correct. An exothermic reaction is one in which reactants are having more energy. Reactants have more energy than the product. Option A is correct. Second option they have given reactant have less energy than product, that is wrong. Then reactants are at higher temperature than product, there is no question of temperature. Then reactants are at lower temperature than the product. So option A is correct. Question number 48. If the enthalpy of B is greater than A, the reaction A to B is enthalpy of B is greater than A. Reaction is A to B. This is 110 and this is 100. So what is the nature of this reaction? Endothermic reaction. So let us see the options: endothermic, exothermic, instantaneous, spontaneous. Here A, it is endothermic change because B has greater energy than A. Next question, question number 49. Conversion of oxygen to ozone represented by 3O2 giving 2O2 is an endothermic reaction. Enthalpy change delta H accompanying the reaction is delta H, 3O2 converted to 2O3. The reaction is endothermic. Since reaction is endothermic, what is the value of delta H? For endothermic reaction, positive. For exothermic reaction, negative. Therefore, delta H is positive for this reaction. Option B is correct. Question number 50. The enthalpy change when 1 gram equivalent of acid is exactly neutralized by 1 gram equivalent of base in dilute aqueous solution is known as, what is the name of reaction? Acid react with base giving salt and water, neutralization reaction. And what is the change in enthalpy? That is enthalpy of neutralization. So acid react with base, the enthalpy change is known as enthalpy of neutralization. They have given heat of formation, heat of solution, heat of sublimation and heat of neutralization. So last option D is correct, that is known as enthalpy of neutralization. Next, question number 51. Enthalpy change for the reaction is called, they have given a simple reaction, half H2 plus half Cl2 giving HCl. This is gas, gas, gas. So 1 mole of HCl is obtained from its constituent elements. The process in which a substance is formed from its constituent elements is known as formation, and the enthalpy change is known as enthalpy of formation. That is the enthalpy of formation. So for this reaction, enthalpy change is known as enthalpy of formation. Correct option is C. It is the enthalpy of formation. Now question number 52. See question number 52. Here they have given one reaction, H2 gas plus half O2 gas giving H2O liquid, delta H minus 284.5 kilojoule per mole, and the enthalpy change for the formation of 3.6 kilogram of water we have to calculate. Here is the problem. calculation we have to perform. The reaction given is H2 gas plus half O2 gas giving H2O liquid. For this reaction, delta H will be minus 284.5 kilojoule per mole. See the meaning carefully. In this reaction, water is formed from its constituent elements. So it is known as enthalpy of formation. Just now we have studied. This is known as enthalpy of formation. What is the mass of water formed in this reaction? 18 gram. So whenever 18 gram water is obtained, the change in enthalpy is minus 284.5 kilojoule. For 18 gram water, this is the change in enthalpy. They have asked to calculate the change in enthalpy for 3.6 kilogram. 3.6 kilogram means how many grams? 3600 gram. For this reaction, 1 mole of water is formed. That is the enthalpy change, heat evolved. So what is the heat evolved whenever 3600 gram water is formed? 18 gram this one, 3600 gram of water is equal to X. Doing cross multiplication, X will be equal to minus 284.5 into 3600 divided by 18. If we solve this, 18 2s are 36, so 200. X will be equal to minus, multiply this factor by 2. There are 2 zeros, 0, 0. 2 5s are 10, 1 is carried. 2 4s are 8 plus 1, 9. 2 8s are 16. 2 2s are 4 plus 1, 5. 1. So here it is 1. Minus 56900 kilojoule is the enthalpy change whenever 3.6 kilogram of water is obtained by this reaction. Now see the options. They have given option A minus 284, plus 284, B minus 284, C minus 5690 and D minus 56900. So option D is correct. Question number 53. Which of the following is reaction represents enthalpy of formation of AgCl? Enthalpy of formation of AgCl. Formation is the process in which 1 mole of substance is formed from its constituent elements, not ions. Constituent elements, and constituent elements are present in which option? See the 4 options. First one is ions, so not correct. Second, directly substance given, not correct. Third, AuCl molecule is given, so not correct. Last is correct because only elemental silver and elemental chlorine is involved. The reaction in which a mole of substance is formed from its constituent elements is known as enthalpy of formation of silver. Therefore, option D is correct. Last option is correct. Now, question number 54. The enthalpies of elements. Enthalpies of elements in their standard state are 0. Standard state are 0. At what temperature? What is the standard temperature in thermochemistry? 25 degrees Celsius. That is 298 Kelvin. So option A is correct. Standard enthalpy under standard temperature in elemental state is considered to be 0. Option A is correct. Now let us see some questions from critical thinking. Question number 51. Now see the question from critical thinking, not classical thinking. Question number 51. This is 51 from classical. This is 51 from critical thinking now. Question number 51. The mathematical expression for standard enthalpy of sublimation is given by. What is the enthalpy of sublimation? It is the enthalpy change whenever 1 mole of solid is converted to gas without passing through liquid phase is known as enthalpy of sublimation. Therefore, enthalpy of sublimation is the summation of enthalpy of fusion and enthalpy of vaporization. See the 4 options. In the third option, they have given the summation, enthalpy of fusion and enthalpy of vaporization. They have given summation in third option C. So that is correct. Question number 52. In which of the following thermochemical changes delta H is always negative? Option A, enthalpy of solution. We have seen enthalpy of solution may be positive or may be negative depending on the crystal lattice enthalpy and solvation enthalpy. So that is wrong. Second, crystal lattice enthalpy that we have studied, it is positive. So that is also wrong. In the previous syllabus that is considered to be negative. Here it is always positive, we have studied. Then enthalpy of atomization, where atoms are obtained from molecule, that is always positive. Enthalpy of dissolution. Enthalpy of dissolution means formation of solution. It is also may be positive or negative. So no option is correct. In the previous syllabus, it is the crystal lattice enthalpy considered to be negative. Here we are considering that as a positive. And therefore no any option is there. Now question number 53. One more important question, very good question is there. Very good question. An athlete is given glucose of energy equivalent to 880 kilojoule. One runner, athletics player means runner, has given the energy is equal to 880 kilojoule. He utilizes 50% of that. Question number 53. Athlete is given 880 kilojoule. He uses 50%. 50% means how much divided by 2. So he is using 440 kilojoule of energy. Athlete is using. Then an athlete is given glucose energy equivalent to 880 kilojoule. He utilizes 50% of this gained energy in the event. For running event, he uses 50% energy in order to avoid storage of energy in the body. The weight of water he would need to perspire is, how much water he must perspire. That is what we have to calculate. So let us write the reaction of glucose. C6H12O6 plus combustion O2 converted to 6 CO2 gas plus 6 H2O liquid. 6 to the 12, 6 18, so 6 gone. Here it will be 6 O2. This is the reaction. By this reaction, how many moles of water are obtained? 6 moles. They have given the data. Whenever 1 mole water is evolved, how much energy? 44 kilojoule of energy he is getting. 44 kilojoule energy he is getting from 18 gram water. 18 gram means that is 1 mole of water is equal to 18 gram gives 44 kilojoule of energy. How much energy he requires? 440 kilojoule. 440 kilojoule energy he requires. 1 mole gives 18 gram is used 44 kilojoule energy. 440. So how many grams? This is 10 times. This is also 10 times. Means 180 gram of water he must perspire for that event, for that running competition event. And they have given options 18 gram, 1.8 gram, 1800 gram and 180 gram. So last option D is correct. So with this, here we have completed questions on enthalpy of phase transition, thermochemistry, thermochemical equations. The next part, that is questions on bond enthalpy, we will see in the next lecture.